Hello, everyone, and good morning. I am Kevin Stolarski, and I will be your host for today's Technical Kemping webinar, where we will be covering setup best practices and configuration basics. And with that, I will pass it over to Mike Bamba, Principal Solution Architect for Kemp, who will be our speaker here today. So, Mike, take it away.
Yeah, good morning, good afternoon, good evening, everybody. Thank you for spending your time with me today. I'm a 36-year government veteran, so now about 45 years, I guess, total in the industry, in the area of information systems engineering and technology in general. Progress Technology bought Kemp Technologies about 2 years ago, and we're going to be talking about the LoadMaster product line from Kemp that's now Progress's product in this discussion. But there'll be also a lot of information here that is just general purpose about load balancing. You know, what is load balancing? How does it work? Things of that nature. Progress has a large portfolio of products. Our vision is to propel businesses forward in a technology-driven world, which includes a technology, for example, to build the backend for web infrastructure, to put applications into the network, to be able to deploy those at scale and to be able to operate them and defend them as well. Our mission is to be your trusted provider, and our strategy to get there is a combination of innovation, investments, and then significant effort around customer satisfaction. Today's agenda, we're going to talk about load balancing basics, set up best practices. We're going to take a little delve into automation, what you can do with the API interfaces on today's technology, including LoadMaster. And then there'll be a questions session and answer session at the end of the webinar. So first, for load balancing basics. Application load balancers sit logically or in the path between the users of an application and the servers that host the application. The purpose for a load balancer is to load balance. It takes requests in from users, it looks at a backend pool of servers, and it sends that traffic to a backend server that is working properly. So the user gets connected to a backend server. Load balancers were originally put in place because application servers weren't big enough to handle the total load from users, and they had the IT departments needed to deploy multiple backends. They tried to use DNS for load balancing initially, but DNS doesn't know whether servers are up or down or applications are working or not. And the experience that the customer base had was not exactly stellar. So they would get someplace around 50, 60, 70% happy customers, but until they put load balancing in place, until we ended up with a way of knowing the backend application servers are actually available to take a request and able to satisfy the request, the customer satisfaction ratings didn't go up. Today, all major information systems, everything you see out here, everything you use on the internet, uses load balancing in front of it to ensure the customer gets connected and is able to deal with scaling depending upon whatever the type of service is. Application load balancers, they're designed to health check the backend application servers at the application level, which means it's not just simply a ping to a port or a TCP connect to a port to see whether the service is up and running. It's actually being able to interrogate the service, the application, and make sure the application can provide an adequate response back. Application load balancers, what I mentioned earlier, scalability was the reason that these first went into place to deal with scaling workloads. Today's solution sets allow for dynamic scaling, with Kubernetes and clustering and dynamic on-demand infrastructure provisioning. The application load balancers today, most of them, ours included, are able to recognize when changes occur at the back end and scale the number of servers available for an application automatically. Application load balancers, or as they later became known as application delivery controllers, ADCs, became security appliances very quickly during their deployment history. And that's because they were the device the user connected to. The users didn't connect to the backend application servers anymore. They connected to the ADCs, the load balancers. That meant that the load balancer would protect the application servers from the users trying to directly attack those backend application servers. The general term in the industry is reverse proxy. So if you hear that term reverse proxy when you're talking to your counterparts, what they're talking about is a device which takes a user connection and makes sure that the backend servers can't become compromised as a result of that user trying to connect to them, asking for data from an application. There are a couple of ways to deploy load balancing technologies. One way to do this is what's called a single arm configuration. And to try to make this as simple as I can, a single arm configuration is when the load balancer, the connection the user makes to the load balancer, that connection is on the same network as the application servers are. So in that case, LoadMaster has a virtual IP address the user connects to. It's actually a true IP. We call them virtual IPs, but it is an IP that you would find on the internet, registered in DNS. The user connects to that IP address, which is the load balancer. In the case of a single arm configuration, that IP address is on the same subnet as the application servers are. Two arm configurations, more of a traditional DMZ approach, where the load balancer is connected to two different networks from a data perspective. One network would be the DMZ network, which the users would come into, and the other network would be the network the application servers reside on. Now we're going to get into some setup best practices on load balancers, and this is focused specifically on LoadMaster product line, but you can infer from this what you would require for any other application delivery controller. So at first boot, when you first boot up an application delivery controller, it doesn't know what network it's supposed to be on. So the first thing you need to do when you apply power to a new network device is assign it an IP address and a subnet range and default gateway and DNS servers or name servers associated with it. So that's the first step in any load balancer deployment, whether it's a physical appliance, in which case you'd rack it in the rack, you'd apply power to it and apply a cable to the Ethernet 0, the default interface on the appliance, and then make sure that connection to Ethernet 0 is something that you can reach with a management workstation. And then you power it on, it'll boot up, and you can connect the console to the device, or in the case of virtual appliances, the console is available as part of the hypervisor service, and you'll be able to watch the boot process, and at the end of that boot process, you'll be able to sign on to the appliance and set its IP address information. Once that IP address information is set, the next step is to license the appliance, and that's done through our web user interface. So you go to a browser, connect to the IP address you configured earlier in that first step. It will take you immediately through a workflow for licensing. So the initial licensing is before any passwords are set on the appliance, permanent passwords are set on the appliance, and the initial licensing uses what we call a Kemp ID. It's an ID you register with our company through our website that allows you to, one, download virtual appliances, and number two, license appliances. So use that Kemp ID to license the appliance with. If you purchased the product, you'll get a contract number, and you can enter that contract number in the same window during licensing. And this will allow you to get a permanent license. If you don't have a contract number, we will offer you a 30-day evaluation license as the option when you do the licensing process. After licensing, typically you'll want to assign the device the rest of its IP configuration information, what its host name is, what its search domains are, adjusting any of the name server, DNS server information that you initially entered in if you wanted to add additional ones or remove ones, setting the search domains for DNS. So you set up the DNS and name configuration for the appliance. Then network time protocol, the ability to synchronize time on these appliances is really important. If you don't synchronize time, then the log files the device generates can't be correlated with anything else in your network from a time perspective, at least not efficiently. Also, the time is critical for how cryptography works today. So if you're doing TLS offload on the appliance, if you're just trying to connect to it to manage it, you're going to connect to it using a TLS connection, transport layer security. Those connections, if time is not set properly on the appliance, if the appliance drifts too far from the same time that the other devices on your network think is proper, then cryptography won't synchronize. You won't be able to connect to the device. So network time is really important. That's the next thing that you would do to configure the system. Now it's time to look at the appliance, and our appliances have the ability in the virtual space to easily support 8 network interfaces. It's really dependent upon what the hypervisor will provide as far as the number of network interfaces. In the physical space, we have different hardware appliances that vary in the number of network interfaces they have, up to 20 network interfaces on one device. So you don't have to use them all. Most customers don't use them all. So what we would recommend you do is go ahead and finish configuring your network, config and connect up the rest of the interfaces to the proper port group switches, VLANs in your network. So that's the next step, is configure the remaining part of your network. We do recommend you explicitly assign the management gateway. So in most of my customers, when they deploy, what they will want to do is they'll want to dedicate a network interface for management. And then they'll want to dedicate a network interface for high availability traffic if we're doing high availability configurations. And then they'll want to dedicate the remaining interfaces, not necessarily all of them, but some of them, for the application workloads. Whether it's split it, so we do the 2-arm configuration where some interfaces are associated with the DMZ and some associated with servers, or in single arm. Again, so that next step is actually doing that network interface configuration. We do support bonding, which means combining multiple interfaces together to increase the amount of bandwidth available and provide additional resiliency in the case of a media failure. For example, if you bonded 4 10-gig interfaces together, you would get 40 gigabit of potential throughput. If one of those interfaces, if something happened at the media level, a fiber breaks, a transceiver fails, it would automatically step down to 30 gigabits of throughput. So you wouldn't lose connectivity, you would just simply lose part of the size of the pipe. So a lot of our customers will go ahead and create those bonded connections and add at least one extra interface beyond what they require to make sure that if there is any kind of failure, interface-wise, switch-wise, cable-wise, that the throughput they desire is still achieved. The device, when it first boots up, when it first licenses, the default gateway for the appliance, which is the gateway that it would use to make any outbound request for anything, that default gateway is assigned to the management network. So when you get to this point in configuration where you've actually configured a data plane for your device, for load balancing the actual application workloads, we recommend you move your managed default gateway over to the data plane. And that's what the next step in the process would be. To ensure that the appliance operates as securely as possible, we recommend you install your own organizational certificates, X509 v3 certificates. You can source them internally, you can source them from an external PKI service, but what the device will have when it first starts up is a self-signed certificate on it. And while technically it is secure, from a policy perspective, with most larger organizations, it doesn't meet their requirement, which is, organizationally derived certificates should be used for management and for the application workloads themselves. So you'll get the certificates, install them. You have an option to set your TLS versions. You can have up to the TLS 1.3 is supported today. So a lot of our customers, because TLS 1.2 and 1.3 are easily supported in today's modern browsers, will go ahead and limit the TLS versions to 1.2 and 1.3 as an example. These provide a higher level of security than the earlier TLS versions. You can also specify your cipher sets. By default, we use the best practices cipher set for application workloads, but you can pick the US government FIPS cipher set if you choose. and then you'll be using cryptography that has been vetted by the US government in their testing labs at NIST. The default account on the appliance when you first boot it up is BAL, for balance, or BAL. That default account is something that you can't delete. Yeah, it's going to be there forever. It's really used as an emergency restore account in case something else happens with your other accounts and you have no way to get into the locks. You would use this default account. Well, it's not best practice from a security perspective to manage your appliance using a default account. You should manage it with an account which you can attribute to an individual. So if Steve is one of your administrators, you might want to create an account, admin Steve on the appliance, and then that would be what Steve would use whenever Steve signed on, or Susan, or whoever, to manage the appliance. And then the last thing is you'd go through some standard configurations on the appliance related to how its settings work globally. So what does this look like? So when you first boot the appliance, you have a choice on a hardware appliance to connect the console up. And the console can be connected using a VGA cable to a standard VGA monitor and a USB-based keyboard. That's the simplest way to do it. We also offer a serial interface on the appliance, and you can plug it into a serial console using a product like PuTTY to go ahead and see what's happening during the boot process. During the boot process, at the end of the boot process, it's going to present a screen which is going to show you the default name, BAL, and the default password, 1 for all, the numeral 1, and the word FOURALL. And it'll show you those, and you can then use those to sign into the appliance so that you can set the IP address. That setting the IP address is workflowed. So as soon as you sign on, the first thing you see is this first pop-up screen, which I'm showing you now, which is go ahead and enter your IP address and subnet range. After you've completed setting up the network interface settings, you'll be asked to commit the change, and the appliance will direct you to use a browser to connect to that new IP address. So when you connect to the new IP address, the first thing it's going to do is take you straight to licensing. The licensing process uses your Kemp ID, your Kemp identifier, and the associated password for your Kemp identifier. And these things, again, if you go to kemptechnologies.com and you click on the login page, or you click on the trial button, you have the opportunity to create a Kemp ID. And once you get that Kemp ID created, you'll get an email that says confirm it. Once you've confirmed it, you have an active Kemp ID, and you can use it to download evaluation versions of our virtual appliances, or you can use it to license appliances with. If you did order it, if you purchased the product, you'll get another piece of paper and email virtually from us, and it will indicate the Kemp order number. And that order number is what you would put into the next box down if you wanted to immediately go to a permanent license. Without that order ID, the screen that you would get during the licensing process would show only an evaluation license available to you. You can use the API interface to license with. So once you've set the IP address, you can use the API interface to do everything else. You can license the appliance with the API interface. You can configure everything with the API interface. Everything that's available in the web user interface is exposed through the API interface. So now that we've licensed the appliance, we need to go in and set some additional information about the appliance. What is its name? In this case, this one's name is VLM1. What is its search domain? In this case, it's progressdemo.com. Any name servers, if we had a couple, we've got them in there. If we need to add some, we can add some. As you can see in here, we don't differentiate when you enter an IP address. If you enter it in IPv6 format, then we recognize it as an IPv6 address. If you enter it in IPv4 format, we recognize it as an IPv4 address. So if you're looking for a separate button that says enter IPv6 addresses, you're not going to find it, because we consider IP as IP. Intelligence is built into the platform in the back end so that we can recognize what type of address that is and use it appropriately. Network time service. It's an option off of the menu. Again, you'll go into system configuration, system administration, and date time. And in that section of the web user interface, you'll find the settings for network time service. We support authenticated network time service, which means NTP v3. So if you do have a requirement to use NTP version 3, which is a more secure version of network time service, then we have that built into the platform. But most of my customers still are using the standard NTP service, and you put in the NTP service name, click the set button next to it, and wait for a few minutes, maybe a minute, maybe a little less, and it'll pop up a dialog box showing you the time offset, which means it was able to successfully talk to the NTP server and it adjusted the time offset on the LoadMaster to match that NTP server's global time settings. You can also set your time zone. This is optional. So if your data centers all run on UTC, otherwise known as Greenwich Mean Time, otherwise known as Zulu time, if they all run on that time zone, then just leave it like it is because that'll be the default setting. But if you adjust your time zone settings on your network appliances to match the country you're in or the region you're in, then please go ahead and adjust it here as well, so that your logs will all show up to match the same. You configure the remaining interfaces, and if you notice under system configuration, under network setup, you'll have an interfaces option, and it'll show you the other interfaces that are available on the appliance, and you can go into each one of those and assign an IP address to it. We do not support multiple interfaces on the same subnet. So the only key here that you need to recognize is if you put an address in and it comes back and errors out, it's likely because you tried to put an address in that's on the same subnet as one of the other interfaces is. So each interface should be on a different subnet. You can bond interfaces together before you assign an IP address. When you bond them together, that bond group will show up as an interface type, and you can assign an IP address to that bond group. If you want to assign VLANs, you can assign VLANs to these network interfaces, and then you can assign IP addresses at just the VLAN level. They give you that level of flexibility. The admin gateway, because we do recommend that you have a dedicated management interface and a dedicated control plane for things like HA synchronization traffic, and then additional interfaces to use for your application load balancing requirements. You are going to want to move your default gateway over to your application plane, because if that server has to go out and make a request for something, you want that to work properly. For example, the server makes a DNS outbound request, it goes through the load balancer, and it won't in all cases, but it could. We want to ensure that that traffic goes back out properly. If a user comes into the load balancer and attaches one of the virtual services, one of the applications you're load balancing, then the response goes back to the user. It needs to know how to get back to the user, what router to connect to send the traffic back to the user. So that default gateway is going to move. When that default gateway moves, you have the risk of isolating your management interface. So how do you fix that? Well, you put in the gateway address for the management interface. You specifically define it in the platform. And that's what you'll see in here under admin default gateway, is we've assigned 10.0.0.2 as the default gateway for administration purposes on the appliance. This is also where you have an opportunity under this remote access to set your outbound cipher set. An outbound cipher set is when the load balancer makes an outbound TLS connection, and it might do that to an LDAP service for authenticating users, as an example. When it makes that outbound TLS connection, it's going to list in its request for that connection the ciphers it supports. And you can adjust that list of ciphers that gets presented to the other system by adjusting this outbound cipher set dropbox. To configure alternate gateway support, you have to first tell the appliance you want to be able to move the default gateway, and then you need to move the default gateway. To tell the LoadMaster you want to be able to move it, you need to go to under System Administration, Miscellaneous Options. There'll be a Network Options setting that allows you to enable alternate gateway support. So you just check that box and you can enable alternate gateway support. Once you've enabled it, then the network interfaces will have an option that says use for default gateway. And that option is what you would check. And when you check that option, what happens is additional dialog boxes will pop up asking you to define the default gateway for that interface. You will type in the information for that default gateway, and then the appliance will move its default gateway to that other interface address. Not the network interface address, but the default gateway that's assigned to that other network interface. SSL certificates are important on the appliance. So you'll need to configure SSL certificates, both for getting rid of any error message you might get on the browser when you connect to a web browser for managing the appliance, as well as for any applications you're load balancing. You want to bring in certificates. If you need to terminate the TLS connection, you'll need to have those certificates loaded on the appliance. There's an import certificates button under the certificates and security SSL certificates area. And that import certificates button will tell you a little bit about the format we can support for importing certificates. The format is PFX or PEM for the web user interface. So in the web user interface, you can import a certificate in either PEM format or PFX format. You can also import a certificate where it is a two-part file, where you have one part which is the cert file and the other part which is the key file. You know, and you can bring those together using the web user interface to go ahead and import certificates. When using the API interface, the format that's required for importing certificates is PEM, and that's all we use is PEM for the API interface. Once you've imported them, they'll be shown on the appliance in this list of certificates, and from there you can assign them for different purposes, to include managing the appliance. So if you see administrative certificates listed in the bottom of this little, right down in here, what you'll notice is that one's been assigned now to this wildcard certificate called kemptech.biz. Adding additional administrative accounts so that you're not using the BAL account is important, so that users can, so the log files on the appliance, and we log everything. All changes to the appliance get logged. All logins get logged, and it's all in what's called an audit log file. The audit log file is one of the few files on the appliance that you cannot delete. So it's going to continue to grow in size, but the amount of data that goes into it's fairly small. So it's not, we haven't had any customers with a complaint yet about overfilling their audit log file. But it will have in it the from IP address, the user, whoever connected to the appliance, the name of the user that signed on to the appliance, you know, whether the sign-on was successful or not, and what the user did while they were connected to the appliance. So when these admins are on there making changes, every change they make gets written to the log file. Cipher sets, again, if you're going to be connecting up, you should be adjusting your cipher sets to what your organization requires. In this case, this is for the web user interface, where you can set the cipher set for an inbound connection to the LoadMaster management interface. So you can define the cipher sets you want to use. I picked a cipher set called best practices. There are actually lists of cipher sets on the appliance. Under that certificates and security cipher sets button, you can see all the cipher sets that are available, and you can see what ciphers are assigned to each cipher set. You can also create custom cipher sets. You can this is also where you would adjust the TLS versions you want to use. And for TLS 1.3, it's where you can adjust the cipher sets you want to use within TLS 1.3 as well. There are additional configuration items you'll want to do for most organizations. Once they've configured the individual LoadMaster appliance, if they're going to have an HA pair, a high availability pair, which is one active, one standby, synchronizing information between the two of them, what they'll do is they'll configure two appliances, license two appliances, And then when they're finished with the steps I've shown you, they will combine them into an HA pair. That combination process is fairly simple. It's a menu item on the appliance that says HA, and you assign one as the first mode and one as the second mode. The one you assign first overwrites any virtual services configurations onto the one you marked as second. And after you've combined the two together, then you manage them as one device. You don't manage them as two different devices anymore. Geo load balancing, another feature set that's available in the LoadMaster platform, which is a health checking, persistence capable, advanced scheduling DNS service. So it's DNS where you can pick something other than round robin as how you want to hand out DNS answers. It's DNS where you can health check the application or the server or both to make sure that the backend IP address is actually working properly before you hand it out as part of a DNS query. And it's DNS where if a user comes in and makes another DNS query within a certain period of time, and you can adjust the time, you can give them back the same IP address as a response. So that will allow you to have persistence or keeping users connected to the same backend server so that if they need to complete some work they've started on that server, they can complete it if they go off to lunch and come back and sign back in again. So that is Geo in a nutshell, is the ability to do load balancing using DNS, but not having to lose any of the functionality or that you would have in application load balancing, meaning you have health checking, you have advanced scheduling, and you have persistence capabilities. If you're going to use LDAP, either for the applications, for pre-authenticating access to an application, which we can support, or if using LDAP to hold the accounts for managing the LoadMaster appliance, then you'll need to configure the LDAP settings as well. We do recommend you use a syslog server for long-term persistent log storage on the appliance. SNMP, we can configure the appliances for simple network management protocol all the way up to version 3 of that protocol, so that it can report into your network management tools you have today. That's up, down status, standard health of the appliance type information. We also have some traps that can be sent rated to application events on the appliance. And then we can also do email logging. So you can configure the appliance to send an email event to an administrator based upon the severity of the event, much like syslog. When you create virtual services on an appliance, and this is in that best practices section again, when you create a virtual service, we recommend that you allow the LoadMaster to NAT the client IP address as it goes to the backend server. That should be your standard configuration when you create virtual services, and you should deviate from it only when you have to. And this has to do with how TCP/IP operates. It's an internet plumbing thing. So TCP/IP operates over what are called connections. So once that connection is established, it's established between two devices. With the load balancer in the path, logically or physically, in the path to the application, the user connects to the load balancer. So that initial connection, that pipe is connected from the user to the load balancer. And when the user wants to get some information from the application, it sends that request through that pipe to the load balancer. So the load balancer will normally NAT the user's request, and it will create a connection, a pipe, between the load balancer and one of the backend application servers. And it will then send that request to the application server. And now, because the application server sees the load balancer as making that request, it gets a response back to the load balancer. So this ensures that requests and responses all take place inside established connections. There is another way to load balance, and that's called transparent load balancing. And transparent load balancing, the user's IP address is not changed. It is simply forwarded through to the backend application server. The application server will get now an IP address that it does not have a connection to. And it will typically respond, but if the connection doesn't exist, than if, for example, your application servers are on private address space and your users are on public address space. If your application servers are an unroutable area and the load balancers are the thing that blocks traffic, so that only user traffic gets to the application servers. There are many reasons why that connection will not get back to the user if you have transparency enabled. There is a simple way to solve that problem, and that is the application servers can use the load balancer as their default router. And the load balancers, these LoadMaster appliances, are intelligent enough to know that if it sent a request and it gets a response back from the application server, even through routing-based methodologies, to go ahead and forward that request back to the user through an established connection. So the user would get the data back. So there is a way to deal with transparent load balancing, but it requires using the load balancer as the default router. There is one other way to deal with transparency, and it's called direct server return. And we're not going to talk about that too much during this because it gets to be complicated. You have to configure each and every application server in order to make it support direct server return. Suffice it to say that if you are doing transparency, I do recommend that you just burn one of your support tickets, open up a call with our support guys, tell them what you're planning to do, have them give you a little bit of help, because most customers that try transparent load balancing on any platform from any manufacturer, they fail on the first attempt and they end up calling support anyway. So you might as well get ahead of it and just tell people you need to do it and why, and we'll help you get that set up properly. Let's see. And we're going to go now into a little section on automation. I'm going to show you some of the things we talked about. And then I'm going to, after that demonstration of what we did, and then an automation discussion on how we can use automation to improve the overall speed of deployment for the application, for the load balancers, we'll have a Q&A session. So this is one of the load balancers. Let me go ahead and go one more step back. This is what the console interface looks like in a hypervisor. When you first install one of these appliances, you import it into the hypervisor. We actually offer, when you look at the downloads from us, in that download will be an OVF file, which is a template file. There will also be a VMDK, a disk file, a virtual disk file, and there'll be a document on how to put it all together in your hypervisor. So if you download a virtual appliance from us, you'll get in that single package, a document, and then the two files you need to actually bring that into your hypervisor. The template file is what you will typically use when you import an appliance, and you have to give it a name. And this has to do with both what are you going to see in your hypervisor list of virtual machines, and where are you going to store the resulting disk file, because the disk that you copied from our website, that package, it doesn't get directly used. It gets used to make a copy of itself and put into the folder the hypervisor, this step in the hypervisor process picks. Once it's brought in, because the template file will go ahead and provide additional information to the hypervisor on what the initial settings need to be, you'll get a machine which has, in this case, 2 gig of memory assigned to it, 2 processors assigned to it, a disk assigned to it, and 2 network adapters, and then a display. Now, the network adapters right now haven't been assigned to port groups. The step you would do next to get anything done is you would assign them to port groups. I'm going to use some built-in ones in VMware Workstation. And at this point, we now have network adapters assigned to different port groups, and you power on the appliance. When you power on the appliance, a little bit. It will boot up, and you can watch the boot process. At the end of the boot process, you will see the default name and password on the appliance. And you can use that default name and password to sign into it and set the proper IP address for this appliance. For example, this one shows up as, the val and one for all, or the password. The initial appliance picked up an IP address via DHCP, but we don't want to use that. We want to assign one specifically. In most cases, that's what you're going to want to do with any network-based appliance, is not use DHCP-generated addresses, but use permanent addresses. And once you start the sign on, it takes you straight to workflow. So we're going to go and assign this one IP address 35 in this network range. Leave the gateway alone. I'm going to change the DNS name servers. We need to add a space with separated list in here. There is no proxy in the path between the user and the managed workstation, between the load balancer and the managed workstation. And then we say we're going to commit those changes. Now those changes have been committed. Now IP address, that appliance is now listening on IP address 35. So if I go to a browser, oh, sorry, let's say 35. Apologize. Let me change this. We're using this address. We'll go straight to licensing. That's what happens with this. And so I'm going straight to licensing. I'm going to go ahead and enter my Kemp identifier. And I'm going to enter my Kemp identifier password. And I don't have an order ID right now. I'm going to show you how to do an evaluation license. I'm assigned to my appliance. I'm sorry, I'm using a licensing server here, which automates the process. So I can pick a license I want out of the licensing server, or I could have got if in the case of the traditional method, what you would see here, you would see a eval license as an option. So this one, pick one of these. What's happening in the background is the license is being generated on a licensing server that's being copied to the appliance. Okay. Once licensing is completed, you need to assign a password. We won't let you not assign a password. And then you sign on the first time with the BAL account and that password you just did. The settings again, SIPs configuration, network setup. The first thing you'll want to do is assign the host name to it. You want to give it a search domain, which is equivalent to the domain associated with the host name. And at this point, you've completed what you need to do here, unless you want to change the DNS settings. After you've done this, you're going to want to go in and set network time service. It'll sit there and it'll chug for a little while, and it'll show the time offset, and then you know the time services are set properly. There we go. So network time service is successful. You can optionally change the time zone. If you notice up here, mine is showing like 3:46 p.m. right now. If I set this to Arizona time, which is where I'm working from right now, the time will change up in the top corner. to show 8:46 a.m. now for Arizona time. So time zone settings, you want to create a user account for that appliance. You go in here. Add a user. After you've added the user, you'll want to assign the rights to that user. First user, you'll probably want to have all rights assigned to. And at this point, you can sign out of the appliance and sign back in. And do the remaining settings as that user. So, in a quick nutshell, download the appliance, give it an IP address, go through and set the name for the device, create a user account, and then to make sure that you don't later hurt yourself, go into your root access settings and assign the default gateway, so that you later decide to move your default gateway. If you decide to move your default gateway, you can still gain access to the appliance. So there were other settings I showed you during the presentation and I don't want to run out all the time for this presentation. So the next thing I want to show you very quickly has to do with automation. We can take API commands and put them into a scripting language. In this case, I decided to use PowerShell for the demonstration, but you could use any scripting language you're comfortable with, Perl, Ansible, we don't really care. The API commands, they're basically, curl, open a web-based connection to a port on the load balancer, provide credentials for authenticating the user that's making the request, and then provide the command that through that web-based connection that the appliance should execute. So in this case, we've got this all set up. This script and these scripts, so by the way, if you're working in the government space and you need or you're just working in the regulated industry space and you want to lock the device down, reach out and touch me. I'll get you copies of them. But when these scripts run, what will happen is the appliances will be configured to meet certain standards. In this case, we're doing things like assigning a custom crypto set. We're creating a password user and a certificate user. We can sign on to the appliance using an X509 v3 based user certificate. So if you don't want to use passwords for managing the appliance, you can use certificates to manage the appliance with. You can also use LDAP and you can use Secure ID, to manage the appliance with. So there's ways that you can use multi-factor authentication to sign on and manage the appliance. So once you set the parameters that you want the script to run, you basically run the script, and what will happen is it'll sit down and it'll jump through each of the things that it's supposed to do. And as you can see, we're getting feedback back, so showing me things that it has done, things that it skipped because the parameters were already set appropriately. And at the end of the process, we can go look at the appliance. And this one I'm working on right now is this one right here, which was name and password for sign-on. It was how I was signing on to this appliance a minute ago. So we're loading certificates, management certificates, and intermediate certificates. We're not going to use the Geo service, so we're disabling Geo. We're setting NTP protocol. So for the device, we're creating some user accounts on the appliance because they didn't exist already. And now I'm completed. So I have done all the things we talked about doing now automatically. And if I sign off of this thing, I now will get a certificate-based log on. I'll get a warning banner that says I have to be careful what I do on the device, and I get back into the device. So in that shorter period of time that script ran, I've basically taken this thing to U.S. government security standard baseline settings. So I think that's pretty much all I wanted to talk about during this presentation. We went through real quick the automation stuff, basically the different ways to access it, where you can go ahead and how the Restful API works. Basically just a get or a post, depending upon. We have two versions of the Restful API, two ways to access it, version 1 and version 2. One provides JSON output, one provides XML output. And then some useful links for you. This presentation will be available after the webinar. You can go and download as well. And then did the demonstration already. So any questions y'all may have?
That's great. Yeah, thanks, Mike. Yeah, we do have a couple questions if we have some time. I'll read them off to you here. So one of the first questions, how do we receive the script to harden the load balancer?
Just reach out to me if Mike Bomba, and if you can't remember me, just reach out to Kemp support and tell them that you would like the hardening script for the Kemp appliance, and they'll reach out to me and they can get it to you. But yeah, that's probably the easiest way to do it is either reach out to me and I'll make sure my email information is included on the presentation if it wasn't on the first page, so you can find it. But it's Mike, mike.bomba@progress.com.
Perfect. Yeah, there are a couple questions that we might be better to take offline, and we'll answer them directly to you. I think one easy question here for you. Also, is there a limit to the number of certificates that can be hosted on a single virtual server?
There is, but it's not a small number, and I can't remember what it is. So these virtual servers, these virtual physical or virtual load masters, either one of the two. The ones we sell today, all of them have the ability to support like 1,000 virtual services, 1,000 back-end application servers associated with those virtual services. And that should mean up to 1,000 certificates, because each virtual service could have a different certificate associated with it for TLS.
Okay, I think we have time for one more. So let's take this one. Get a copy of the. Does Kemp develop a wizard for WAF ruling writing? That's
We offer a service that will assist you in writing WAF rules. It's real reasonably priced that you can use. We don't have a wizard of this. The actual WAF rules are mod security based WAF rules. If you can write mod security rules, you can do it fairly simply. I've looked at what the rules look like. They're not very complicated to create. Let's see, any questions on mod security? I think that about answers it.
Okay. Yeah, we are at about time here, and just as a reminder, we will, if there are questions, we will go through them more specific and reach out to you directly to get those answered. As far as the presentation and the recording, as a reminder, we will send out the recording within the next 24 hours. And if you do have any questions in the meantime that come up after the recording, as Mike said, feel free to reach out to Mike or myself or the team at Kemp. But that concludes today's session. We hope you enjoyed today's presentation, and have a great rest of the day, everybody.